Lesson 2.2. In the next 2 lessons, you're going to be learning how to add, subtract, multiply, divide, all the basic operations with radical expressions. So with expressions that have square roots or cube roots in them. What I want to draw your attention to is we're going to skip this first section here and look at this right here. So the strategy is for simplifying polynomials, where we added only like terms together. We're going to use those same ideas with radicals. We're only going to be able to add or subtract like radicals together, and I'm going to show you what that means in a second. So let's say we had this example right here. Cube root, or a square root of 3 plus 2 times square root of 7 plus 4 times square root of 3. The like radicals are the ones that have the same radicand. So this one in blue there and this one in blue here, those are the same radical, or the like radicals. They're not the exact same, but they are the same in that they both have a 3. So what you can do is just add the coefficients or the numbers that are in front of the square root together to combine them. So those two are like radicals, and if there's no coefficient in front, there's actually there is a coefficient. It is technically a 1. We just don't typically write a 1 because multiplying by 1 doesn't change the number, but there is a 1 there. So 1 plus 4 would make 5, and you can put those together. Since 2 to the square root of 2 times square root of 7 is not the same, we can't add it. We would have to leave this, and then this would be fully simplified here. Okay, so we're just going to practice doing that today. That's the main goal of the lesson, is just adding, subtracting radicals in a variety of scenarios. So let's look at the first example here. I'm going to do 1 or A and B, and then you guys can try C on your own if you like. Okay, but I will do A and B. So let's do A. Let's look at the 2 radicals here. They both have a square root of 5. So they are like radicals, and so we can just add or subtract, in this case, the coefficients in front of the root 5. So 9 minus 5 is 4. So this would equal 4 square root 5. And that's all you're doing. You're just simplifying it down into 1 if you can. Okay, let's look at B. I'm going to rewrite B here. So I've got cube root of 24 minus cube root of 192 minus cube root of 375. Upon first inspection, these all look different, and they are all different. However, we can't immediately combine any because they all have a different radicand. But maybe if we write these as mixed radicals, maybe some of the radicals where the radicands will be the same. So let's split these up and write them as mixed radicals. So that's what you want to do in this scenario. So 24, you're going to try and break it up into something that can be evaluated and something left over. So 24 is 8 times 3. 192, I happen to know that that is, I'm going to try a bunch of square. If you're wondering what to break it up into, just have a list of cube roots. So some common cube roots are 8, 27, 64, 125. And just divide them and see if they go evenly. So 192 can be divided by 64. So you want to break it up into 64 times 3. And 375 can be divided by 125. So we break it into 125 times 3. Okay, and then we answer the parts that we can. So cube root of 8 is 2, leaves a 3. Cube root of 64 is 4, leaves a 3. And cube root of 125 is 5, leaves a 3. Ah, look at that. Now all of them actually are like radicals. They all have a cube root of 3, and so we can just add these coefficients or subtract the coefficients together. So we're going to do 2 minus 4 minus 5. So that would be negative 7. And then we leave the cube root of 3. AirPod fell out there. There we go. Okay. So what you want to do when you're adding, subtracting radicals, write them as mixed radicals, and then the ones that are the same or like radicals, you can add them or subtract them from each other. Let's practice doing this when we don't have numbers in underneath, but we also don't just have numbers, but we also have variables. Okay, so again, I'm going to do A and B, and then if you would like, you can try C and check your answer down below. Looks like I have enough space For these ones, since we're dealing with variables, we also have to do this first step that we were practicing in the last section, is identify the values for the variable for which each radical is defined. So we're going to be using some of those same skills we developed last section as well. Okay, so I'm going to rewrite this here. 6 square root a plus 5 square root a minus 11 square root a. So let's just do this first part in green here. These are all square roots, so the radicands must be positive. So that means a has to be greater than or equal to 0. Since the radicands are all a has to be a positive or 0 number. And these are all like radicals. I don't have to do any simplifying or writing as mixed radicals here. I can just simply add the coefficients. So 6 plus 5 is 11 minus 11. Oh, that's 0 square root a, which would just be 0. Okay. And then for part B, let's look at that. So we have 50a squared b minus 8a squared b. Okay, let's first look at the variables. So we have to remember that the radicand 50a squared b has to be positive. If that 50 is already positive and a squared is already positive, you can square any number and it's going to make it positive. So b has to also be positive. So that would indicate that a can be any number, because squaring any number makes it positive anyways, and b has to be greater than or equal to 0. Let's see if that's the same for the second one. Yeah, same conditions, because we have a squared and b again. Okay, so those are the two conditions on the variables. A can be any number because squaring it makes it positive. B has to be a positive number or 0. Okay, now these are not like radicals. They don't have the same radicands. So we do have to write them as mixed. And we did practice that in lesson 1 or lesson 2.1. So let's break this into perfect squares that I can evaluate. So 50 breaks into 25 times 2. So I would break this up into 25, I'll put the 2 later. A squared, I can take the square root of that. And then I'm going to leave any leftovers that I can't take the square root of there. So let's look and make sure this makes sense. The 50 I broke up into 25 and 2. I'll use the same colors here. A squared, I took that out because I can evaluate the square root of that. And then I left the b, because I cannot take the square root of just b by itself. Okay, let's do the 8. 8 can be broken up into 4 times 2. I can take the square root of a squared, but the square root of b I'm going to have to leave. So I'm going to have 2b again. All right, so let's double check. It all looks good. 8 I broke up into 4 times 2. I took the a squared out because I can take the square root of that. And then b I just simply left. Great. Okay, so let's evaluate those. And then I might be able to do some combining. So square root of 25 is 5. Square root of a squared. Since a can be any number, this answer is going to be positive, but I need to put my absolute values around it to indicate I'm going to get a positive number. And then same here. And these are like radicals, so I can add the coefficients or subtract the coefficients. In this case, 5 minus 2 is 3. So I'm going to get 3 absolute value of a times 2b. Okay, there we go. Our final answer there. Okay. Let's go and try an even harder question. So in the next example, it's not going to be any different, but it's just going to be slightly more challenging because there's just going to be more terms. Sorry, my lights turned off there. Let's go to check your understanding number 3. I'm going to be doing, my lights are staying off, there we go. I'm going to be doing part C. You can try A and B for yourself. I'll be doing part C. Okay. Let's look at that one. So we're going to be simplifying this. They've already done the variables for us, so I don't have to do that step. So all I'm doing here is just simplifying. Notice the question asks just simplify because they're taking care of what values of the variables are allowed. Okay, so in this case, a question like this, you want to write it as mixed radicals. So let's just take each term and go step by step. So for the first one, I'll just kind of underline it as I go. So I've got a 3 already sitting on the outside as a coefficient, so I'll leave it there. And then 32, I can break that up into square root of 16 and 2, which I'll leave. 8 to the power 5, so I can take the square root of a to the power 4, and I'll leave an a behind, and I also have a 2 from before as well. So let's just double check this makes sense. 32 I broke into 16 times 2. And then the a to the power 5, I broke into a to the power 4 because I can take the square root of that, and then just a. Okay, so we're going to do that to every single one. I'm going to go a little bit faster now. So 45 I can break into 9 and 5. B cubed I can break into b squared and b, so I'll have 5b left over. So again, I'm not going to highlight every time, but I'll do it this one last time. 45 I broke into 9 and 5. B cubed, I broke into b squared and b, since I can evaluate the square root of b squared. So I'm going to write the other ones just slightly underneath, just like they've done here. So then I'll have 5b, and the square root of 125, I can break that into 25 and 5. I can't take the square root of b, so I'll just leave it underneath. And then finally, I already have a 2a, 72. 72 I can break up into 36 and 2. And then the a cubed, I can break into a squared and a. Okay, that's great. Let's evaluate everything now before I combine. So from the first one, I've got 3 times 4, so 12. The square root of a to the power 4 is a squared, and then I had my 2a left underneath the square root. If you need to pause the video and kind of slow down, you may do so. 2 times square root of 9, that's 6. Square root of b squared, we have to be careful here. It's the absolute value of b. It has to be a positive number. Oh, actually, that's redundant anyways, because they've already told me b is positive. So I actually don't need this absolute value. I can just write 6b. And then underneath, actually I'm just going to squeeze this because I think I can squeeze it all in one line. So 6b square root of 5b. And then the next one, 5, I'll have 25b square root of 5b. And then I will have, for the very last one, 2 times the square root of 36, that's going to be 12. Square root of a squared, so that's going to be a squared, and then 2a. Okay, now here for this one, we'll notice that 2 are like radicals, these 2. And then another 2 are like radicals also. I'll use purple. This one and this one. So we can combine the purple ones together because they have the same radicand, and we can combine the pink ones together because they have the same radicand. Okay. I've done a lot of practice on this, so you might not be as fast as I was simplifying those down, but okay, so at the very end, you should have some that are at least matching. For the pink ones, 12 minus 12 is 0, so you're going to end up with 0 root 2a for the pinks. And then for the purples, negative 6 plus 25 is 19, and everything else will stay the same. Now, since we have a 0 in front of the pink one, we don't actually need to write it in our final answer, since 0 times anything is 0. So let's have 19 times b times square root of 5b. Okay, so if you want to go ahead and try example B and A there, you can do so. Try on your own. And then the answers are down below, so you can check. Okay, and that's the end of today's lesson. I'm just going to stop recording.